some problems from 6.1 and 6.2. This first one here says we have a graph showing two linear equations, and we want to estimate the solution to this system. So you'll notice that you have x plus y equals 9, which is in blue, and x minus y equals -5, which is in pink. And graphically, a system to a solution of equations is the intersection. So for this one, we have to kind of trace down and see what our x value is. This looks like a 2. And then trace over, and it looks like 1, 2, 3, 4, 5, 6, 7. So we would say that the ordered pair 2, 7 is a solution. And you can always check that, right? So here, in our first equation, we have x plus y equals 9. So we can see that 2 plus 7 does equal 9, so that checks out. And then here we have x minus y equals -5. So that would be 2 minus 7 equals -5. We see that also checks out. So this is our system, our solution to the system of equations. In this next problem, we want to solve the system by substitution. So you can solve either one for either x or y. So you want to take a look at it. And here in our second equation, we can see that we already have an x by itself. So that would be, my suggestion is to go ahead and solve this equation equal to x. So to do that, I would have to subtract 3y from both sides. All right, so I would get x equals 4 minus 3y. Well, then I can go ahead and substitute that for what x is in this equation here. So I get 8 times x. Well, x is now equal to 4 minus 3y. Okay, and that is going to give you then plus 4y equals -48. Okay, then we have to go ahead and solve this for y. So we'll go ahead and distribute our 8. So 8 times 4 is 32. 8 times -3y is -24y. Then we have plus 4y equals -48. Okay, so when we solve a linear equation, we always want to combine like terms on each side first. So we have a -24y and a plus 4y. That's going to be your -20y. And you still have the plus 32 equals -48. Okay, and we want to isolate the y term, so we'll do -32 on both sides. Okay, so we get -20y equals, so this is going to be, it's like -80. Okay, and divide both sides by -20. All right, so we get y equals 4. Now, before up here we had x equals in terms of y. Excuse me. So we go back here where we have x equals 4 minus 3y. Well, now we know what y is, so we substitute that in, which we just got to be, I believe it was 4. Yeah. So we put our 4 in, so we get x equals 4 minus 12, or x equals -8. Therefore, our ordered pair, -8, 4, should be our solution. And you can check that by substituting back into the original equations and making sure that you get a true statement. This next problem we want to solve by the elimination method. That means we want one of the variables to drop out. So you have a choice whether you want to get rid of the x or you want to get rid of the y. Sometimes one is easier. I tend to look here. We already have minus opposite signs. So if I were to multiply this top equation through by 6, the y's would naturally drop out when I add them together. So I would just say that's the route I'm going to take on this one. So again, if I multiply this top equation through by 6, I get 12x minus 6y equals 8. And I copy this below it. And if I add these two equations together, I get 13x equals 25. And if I divide both sides by 13, I get x equals 25 over 13. Well, then I have to pick one of my two equations and go ahead and substitute that into it and solve for the other one. Okay, so now we have a value for x. I'll go ahead and substitute in. So here, instead of putting this x, we'll put 25 over 13. Okay, and then plus 6y equals 17. Okay, so I'm going to multiply everything through by 13. 6 times 13 is 78. And 17 times 13 is 221. Okay. And also subtract 25 from both sides. Okay. So I get 78y is equal to 196. And then divide both sides by 78. So you get y equals 196 over 78. And of course, that can be reduced to 98 over 39. Okay. So this one we get an ordered pair, which is 25 over 13. And 98 over 39. And again, these can be checked by plugging them back into those equations.